Welcome to this second video about how to balance chemical equations. In this video we are going to look at some more examples about how we can balance chemical equations. The first example we are going to look at is the reaction between hydrogen and nitrogen to form ammonia. So we have hydrogen gas and nitrogen gas combined to form ammonia. First of all, we are going to write the word equation again. So we have hydrogen plus nitrogen and they react to ammonia. This is the word equation and we are going to transform this into the symbol equation. So we have H2 plus N2 for hydrogen and nitrogen, and they react to NH3, which is the formula for ammonia. This is the unbalanced symbol equation now. So we are now going to look at how to balance this equation. Remember, to balance the equation we need to make sure that there is the same number of atoms on both sides of the equation. So we are going to start again by writing the symbols for the elements involved underneath the arrow. So we have N for nitrogen and H for hydrogen. Remember to always leave hydrogen for last and put the other elements first. Now we are going to count how many atoms we have on each side of the equation. For nitrogen we have 2 nitrogen atoms on the left side for the reactants, and we have 1 nitrogen atom on the right side for the product. For hydrogen we have 2 hydrogen atoms on the left side with the reactants, and we have 3 hydrogen atoms in the product. To balance the equation we are going to start with the nitrogen, and we have 2 nitrogen atoms on the left side and 1 nitrogen atom on the right side. So to balance this we are going to take the 1 atom on the right side and times this by 2, so we get 2 nitrogen atoms on the right side as well. This means we have to put a 2 now in front of the NH3, the ammonia. This means we have 2 ammonia molecules now. This also has an effect on the hydrogen because the hydrogen is involved in the ammonia molecule, so we have to times the 3 for hydrogen by 2, and we then get 6 hydrogen molecules in total now. Now we are going to balance the hydrogen, so we can see that now on the right hand side we have 6 hydrogen atoms and on the left hand side we have 2 hydrogen atoms. So we need to bring the amount of hydrogen on the left hand side up to 6, and the way to do that is to times it by 3. So 2 times 3 is 6, and that means that we need to put the 3 in front of the hydrogen molecule. And now we have 6 hydrogen atoms on both sides of the equation. Now we have the balanced symbol equation and the number of atoms is the same on both sides. Now let us look at another example. So we are going to look at another neutralization reaction, and we have calcium hydroxide and nitric acid react in a neutralization to form calcium nitrate and water. First we are going to write the word equation again, and there we have calcium hydroxide plus nitric acid react to calcium nitrate plus water. This is again the word equation, and we're going to transform this into the symbol equation. So we have CaOH2 for calcium hydroxide plus HNO3 for nitric acid react to CaNO32 plus H2O for water. And this is the unbalanced symbol equation. Now we're going to balance this equation. So again we are going to write all the elements involved underneath the arrow. And as I said in the last video, I would always start with the metal if there is one involved in the reaction, and in this case there's calcium. Then I would look for any other elements that are not oxygen and hydrogen, and we have nitrogen. Then second last, write oxygen, and as the very last one, hydrogen. Now we need to find out how many atoms for each element there are on each side of the equation. There's one calcium atom on the left hand side and one calcium atom on the right hand side. There's also one nitrogen atom on the left hand side, but there are two nitrogen atoms on the right hand side because there are two nitrate ions in the calcium nitrate. Now for the oxygen, we have two oxygen atoms from the calcium hydroxide, and then we have three oxygen atoms from the nitric acid, and that makes 5 on the left. On the right we have 6 oxygen atoms from the calcium nitrate plus 1 from the water, which makes 7 in total. For the hydrogen, we have 2 hydrogen atoms in the calcium hydroxide and 1 in the nitric acid, which makes 3 on the left hand side for the reactants. On the right side for the products, we only have 2 hydrogen atoms in the water. Now we are going to start balancing the equation, starting from the metal, the calcium. You can see that there's one calcium atom on each side of the equation. This means the calcium is balanced and we do not have to do anything about that one. Now we move on to the nitrogen, and for the nitrogen we do have to do something because we have one nitrogen on the left side but 2 on the right side. The easiest way to change this is to times it by 2 on the left side, so 2 times 1 makes 2. This means we have to put a 2 in front of the nitric acid. This 2 in front of the nitric acid is also going to affect the oxygen and the hydrogen, but the nitrogen for now is balanced. We have 2 on each side of the equation. So the 2 in front of the nitric acid means that the 3 for the oxygen from the nitric acid has to change to a 6 because it is times by 2. Also the 1 for the hydrogen has to be times by 2 and changes to 2, so these numbers have to change. Now we're going to look at the oxygen, and we can see that now we have 8 oxygen atoms on the left side and 7 on the right side. Again, we need to bring up the oxygen number now on the right side, and the easiest way to do that is to look at the 1 oxygen that we get from the water. So to bring this number up, we can just write a 2 in front of the water, and that means we get 2 oxygen atoms now, and we have 8 oxygen atoms in total. So the oxygen now is balanced, but the 2 in front of the water also has an effect on the hydrogen. So this means that the hydrogen we need to times by 2 as well, and that means we have now 4 hydrogen atoms on the right hand side. So the oxygen is balanced now. Now we just have to have a look at the hydrogen, and we can see that now we actually have 4 hydrogen atoms on both sides. That means that the hydrogen is balanced and we don't have to do anything more about it, and the reaction is balanced, and we have the balanced symbol equation